Davison and germer experiment. In 1924, Louis de Broglie postulated that all forms of matter have both wave and particle characteristics. According to this hypothesis, electron, just like light, have a dual particle wave nature. Two American physicists, C.J. Davison and L.H. Germer, were the first to experimentally prove the wave nature of material particles in 1927. Displayed here is a block diagram of the experimental setup used by Davison and Germer. It consisted of a nickel chloride crystal, the target, an electron gun, G, and a detector. The electron gun produced a beam of electrons. The electron gun used by them consisted of a tungsten filament, F, and high and low tension batteries. The low tension battery was used to heat the filament. The red hot filament produced an electron beam. A high tension battery was provided to accelerate the electron beam. The detector or the electron collector moved on a graduated circular scale. A sensitive galvanometer was also connected to the detector. How did they perform the experiment? The electron beam was made to pass through a pinhole and made to strike the crystal normally. The electrons scattered in all directions, acting like waves. They observed that at certain angles, the detector indicated a peak in the intensity of the scattered electron beam. This maximum intensity was due to constructive interference, a phenomenon confined only to waves. Thus they experimentally proved the wave nature of electrons. Davison and Germer plotted a graph taking the angle between the incident and scattered direction of the electron beam, phi, along the y-axis and the intensity of the scattered beam at different values of accelerated potentials along the x-axis. The nature of the graph is shown here. From the experimental curves obtained, the following conclusions were drawn. Intensity of scattering depends upon the angle of scattering, phi. A bump or kink always occurs in the curve when phi is equal to 50 degrees. This bump or kink increases as the accelerating potential difference is increased. At 54 volts, this bump is maximum and then it decreases on further increase of potential difference. This peak indicated the wave behavior of the electrons. Thus, Davison-Germer experiment verifies de Broglie's hypothesis of wave nature of matter particles.